Good day, everybody. In the last demo, we have built the solution and we have tested the solution. In this demo, we would see the continuous integration and continuous deployment of the developed integrated solution. This is the architecture of continuous integration and continuous deployment. Git is a local version control tool or software. GitHub is a cloud-based hosting service for Git repositories. Git is a platform or service through which I have hosted my codebase into the Git repository. If there is any push or pull request is performed, then the continuous integration would be triggered. The integrated solution would be deployed in MuleSoft Anypoint cloud platform. Here, all the deployments would occur in the Linux machine. Bash script is used to achieve the continuous integration and continuous deployment. If build generation and deployment of the integration solution is successful, the deployment of the integration and system test case will be deployed in WSL2 Linux machine and execution of the test case will be performed. Now I will execute a single scenario, that is one regression test case, and let us review the results. So I have updated my code base and I am pushing my code base to the Git repository, GitHub repository. So the build, so the build generation has started and the execution is in progress. So if you see, the application is getting updated and it is getting started. So the application is started and the current timestamp. So the deployment is complete now and it is successfully completed. Now the integration test execution has started. The integration test case execution is in progress. So it is deploying in the WSL2 Linux machine. From the WSL2 Linux machine, the execution of the integration test case will occur. The execution of the post integration test cases are being executed on the Linux environment. So the integration test case execution is complete now, and now the system test case execution will begin. The system test case execution has begun. Now, the system test cases, that is Playwright Cucumber test cases, would be deployed in the WSL2 Linux machine, and the execution will occur in the WSL2 Linux machine. So the execution has begun. It is a regression test case, creation of sales order. First, the initial bank transaction will be captured. Now, the computer manufacturer initial bank transaction is captured. Now, the system would log in into the computer doctor sales application, purchase order application, and the sales order would be placed. The sales order is placed. All the details would be retrieved by the automation test script. Once the details are retrieved by the automation test script, it would navigate to the warehouse management system. In the warehouse management system, it would navigate to the sales order. In the sales order module, it would search for the sales order. It would validate all the details and data of the sales order, such as sales order and number, customer, product, unit price, quantity, and total. Everything would be validated. Once the validation is complete, it would navigate to the sales order item module. In the sales order item module, sales order item would be searched and the customer, product, unit price, quantity, and total would be validated. Once the validation is complete, it would navigate to the delivery order module. In the delivery order module, it would validate all the data of the delivery order. Here, the sales order number, delivery order number, warehouse product and movement would be validated. Once the validation is complete, it would navigate to the inventory transaction module and it would search for the inventory transaction and the inventory transaction number, product, stock, movement. Since it is a sales order, there is stock is -1 from which warehouse to customer has been shipped would be validated. Now it is logging in into the ERP application and it would check whether a receipt transaction is created. So in the receipt report module, a receipt transaction is created. All the details such as all the details would be validated. In the computer doctor bank account, whether a transfer has occurred has been validated. And in the computer manufacturer, whether a credit transaction is reflecting would be validated. Now the system test case execution is complete. And now let us review the execution report. So the system test case execution is complete. Let us review the execution reports. Let me download the reports. So this is the postman collection report. It has iterated for one iteration. There are seven requests and other details are mentioned here. So all the test cases are passed. There are no failures. So this is the endpoint which it has hit and these are the validation which it has performed. And all the details are captured in this report in a detailed manner. Let us navigate to the system test execution report. This is a playwright cucumber report. If you notice, it is executed in the Linux environment. It is executed through GitHub action. So it has executed one feature file and it is successful. Creation of sales order is successful. For this data set, the execution is successful. Challenges which are resolved. Development of integration solution into MulePoint, Anypoint cloud platform was a challenge due to license and infrastructure which were resolved. Since my IP address is a private IP address, the applications such as bank, ERP, warehouse management system, sales and purchase applications cannot be triggered. Application test cases cannot be triggered and these were resolved using port forwarding and using self-hosted runner in WSL2 Linux for deployment and test case execution and the test case execution was achieved. Since unit test case requires Nexus connect credentials and connections and it is marked as out of scope and not included for this demo. Next scenario which I have executed is test case with multiple data set. So this is the execution result. The build has passed, the deployment has passed, integration test has passed, and system test case has passed. Since integration test case is same, I would go to system test and review its result since it is our area of focus. So this is the test case execution report. It is a playwright cucumber report. It is executed on Linux environment. It is executed through GitHub action. One feature file has been executed and the scenario purchase order creation has been executed. The scenario has 10 data sets and all the data set execution has passed. So this is executed in the Linux environment through GitHub actions, through continuous integration and continuous delivery. I have executed all the positive scenarios, that is regression test cases, in the through CI/CD And all these steps in the CI/CD has passed. Let us review the system test results. So this is the system test result. It is a playwright cucumber test result. It is executed in Linux environment through GitHub Actions. So four test cases, test scenarios were there, and it is 100% passed. There are four scenarios in it, and each feature file has each scenario, single scenario, and all the scenarios has passed. So this is sales order scenario, creation of sales order scenario, and it has passed. So the purchase order scenario has passed, the purchase order return creation order scenario has passed, sales order scenario has passed, and sales order return scenario has passed. And this is the corresponding data set with which the test case has been executed. Now let us look at we have seen about the deployment, continuous integration, and continuous deployment. Now let us look into the monitoring. MuleSoft Anypoint Cloud Platform has provided a monitoring and alerting facility. Let us view and review it. This is the Anypoint monitoring dashboard. It is the overview tab. In the overview tab, the first tile is Mule messages. This is the number of Mule messages which is invoked by the Mule application. Average response time. The average response time, the average response time of the Mule messages. This is the error count of Mule messages. Mule messages in the sense the inbound and outbound request response time and errors are consolidated here. Inbound. This is the total request by response type. This is the total request. This is the total request, and it has two types. One is failed and okay. And if we, this is the details of whether it is failed or okay. Inbound average response time. This is the average response time of inbound messages. This is the total request and its response type. This is this is regarding the outbound messages. Outbound messages average response time. Regarding the JVM, Mule application has it has JVM processes in it and its CPU utilization. The JVM MuleSoft JVM CPU utilization is data is summarized here. This is the JVM heap used, and this is the JVM thread count. Let us navigate to the inbound messages. This is the total request by response type of the inbound messages. This is the average response type of the inbound messages. The inbound has different APIs in it or endpoints in it. These are its corresponding average response time. Similarly, the mean response time. Similarly, the different APIs or endpoints have this max response time. The different APIs in the Mule application have this response count, total request count. So this is the inbound response time. It is at 90, at 99th percentile, at 90th percentile, at 75th percentile, and 50th percentile. This is the total failure count. The similar kind of data is also generated for the outbound. This is the total number of requests and its response type, whether it is okay or failed. This is the average response time, and uh, the outbound has different endpoints or APIs in it, and its average response time. The outbound has different endpoints and its mean response time. This is the max response time of various APIs or endpoints present in this Mule applications outbound. Outbound has different endpoints and total request which is processed by this outbound messages. Response time of outbound at 90th, 99th percentile, 90th percentile, 75th percentile, and 50th percentile. This is the overall summary of the performance, the number of Mule messages which are processed, and yeah, this is the average response time. This is the overall summary. The Mule application's average response time and inbound messages average response time, and yeah, all the things which are in the different tabs are summarized here. One thing to notice here, yeah, all the things are summarized here. The failure tab holds the information about the failure. This is the number of errors this application, Mule application, has received or processed. Failure uh, total request count. For the total request count, this is the failure. Total request by response type. So this inbound has these two different APIs which reported failure. One is this endpoint, and another is this API, which is an invalid API and which has reported this metrics. Average response time is these min response time and max response time. And this is the request count, failure request counts. The next tab is about the JVM, Mule application JVM. This is old generation garbage count, old generation garbage time, and it has different metrics such as class loaded by the Mule application, heap committed, heap used, the memory, yeah, thread count, and JVM uptime. Various other metrics are captured which are specific to this application and how the resources in the application has consumed or utilized. Regarding the infrastructure tab, Mule applications JVM CPU utilization percentage graph. This is the CPU which is percentage which is utilized by the JVM. This is the heap size utilized by the JVM and the total processes. Number of processes this Mule application has consumed, the memory which this Mule application has consumed, and thread count. These are the various different graphs. Apart from this graph, there are also few other things such as uh, monitoring we just now saw. Alerting is there. We can configure the alert with the subject and message and add the recipient, which is also an useful feature. So we have seen the continuous deploy integration and continuous deployment, monitoring and alerting. Yeah. And yeah, let me summarize what has been demoed in this demo series. Initially, we started with the API specification design life cycle. We designed and an API specification which was simulated, which was given, uh, given for feedback. Product owners, stakeholders, business analysts, various stakeholders gave the feedback, and which was validated by the solution architect and the developers. If validation is okay, specification is moved to the next stage of the life cycle, that is implementation. If there are further review comments or further fine tuning needs to be done, the life cycle would continue. So we saw, as in the agile process, we saw the API specification, how it is designed, how it is simulated, how the feedback is received, how it is validated. Next, I have built an Mule application. The built Mule application for the built Mule application unit test was also built and executed, and it was having 100 percentage coverage and 100 percentage pass result. Next, we move to the testing phase. In the testing phase, I have created integration and system test cases. Integration test cases were created in Postman and JavaScript. All things were parameterized and it was evaluated. System regarding the system test, it was developed using Playwright and Cucumber. Uh, in the system test, all the positive, negative scenarios, business use cases, end-to-end test cases, edge cases, everything were covered. And it uncovered potential flaws, how it may impact the business. Those details were seen in the testing phase. Then we came to the management phase where a continuous integration and continuous deployment, monitoring and alerting were demoed. Finally, the issues which were identified in the testing phase and the issues which operational issues such as operational issues would be troubleshooted and managed, and that is the management phase. So this is the entire life cycle of the API life cycle management which is suggested by the MuleSoft. So two important factors need to be considered here. One is there are few disadvantages in the Mule architecture itself, such as multiple endpoints are clubbed together, and it is that design. Yeah, but there are few disadvantages in it. It is my feedback. Apart from that, the important thing in API lifecycle management is contract. Contract should be well designed and refinement should be proper. Requirement should be refined properly. So it is validated in the initial stages itself, such as in the a design is made, stimulated, feedback is received, validated. So and contract and the validation, initial validation, building the prototype, which is similar to building a prototype for a website. For building website, a prototype would be built. The same prototype model is followed by the API lifecycle management of MuleSoft. So another, as I highlighted, there is a disadvantage of clubbing all the endpoints, inbound and outbound endpoints, multiple endpoints together. So this is the overall demo. This is the overall summary, and we have seen the we. I have highlighted what is the business impact if proper test cases are included. The business coverage test cases, end-to-end test cases, and edge test cases are included. How it can prevent the flaws in the earlier stage, how it can we can prevent the impact in the business. Those things were highlighted. Thanks for your time and thanks for watching.